Next curve.
Hey everyone, welcome to this Next Curve Rethink podcast episode where we break down the latest tech and industry events and happenings into the insights that matter. And I'm Leonard Lee, executive analyst at Next Curve. And in this Silicon Futures episode, we will be talking about the crazy beginning of 2025. I don't recall ever witnessing a January so insane in my life. But anyways, I am joined by the scaled up Karl Freund of Cambrian-AI research and the scaled out Jim McGregor of the famed TIRIAS research. Gentlemen, how are you doing?
Very well.
Happy.
Very well. Confused, but very well.
Yeah, I think he goes out of his way to try to redo the introduction or make it more grandiose at every episode.
Grandier?
No. The proper word, actually, Jim, is ridiculous. There
you go.
Yeah, I told you I have the best words. So.
Yeah, you tend to make them up, though. So I think you're rubbing off on me.
yeah, but I'm good at it, right? So, yeah, this is just pure insanity. But before we get started, remember to like, share, and comment. Share your thoughts on this episode, and remember to subscribe to the Next Curve Rethink podcast. And we're going to get started. Keep that nice and short. But geez, I don't even know where to start, gentlemen. But why don't we talk about? Let's just start off with the beginning of the year, which always kicks off with CES 2025. I know, Jim, you were there. I was there. Let's start off with that. I think maybe we do things in order because, otherwise we'll be all over the map. So let's talk about silicon at CES 2025. What were some of the highlights that you think that the audience needs to be aware of and continue to keep in mind as we go through the course of the year?
Well, I think you have to be aware of the broader trend, and that is AI everywhere. And obviously, we saw that at CES with them trying to put AI in everything, all the way down to a walking cane. It gets a little ridiculous, but we are seeing, and Jensen has talked about these super cycles or super waves, and so has Victor Peng. Talked about, how it's going to be the data center, and then it's going to be the enterprise, and it's going to be the edge. I think we're starting to see in 2025 that edge solution. But at the same time, the other waves are not stopping. I mean, the big news, especially on the silicon front at CES, was Nvidia's introduction of the Blackwell for desktop and mobile.
Yeah.
Their new GPUs, AI GPUs, if you will, for desktop and mobile PCs, as well as what they call digits. This little 4x4 box that they basically crammed a DGX down into a mini box you can put on your desktop for doing AI stuff. And they worked with MediaTek on it. MediaTek actually did the SoC development and integration of it. It used the NVIDIA Grace CPU and the Blackwell GPU into essentially what amounts to a mobile SoC. So it's not stopping. I mean, we definitely see that in the fact that AI is just pushing the boundaries of everything at this point in time.
I agree. I think the Digits platform, to me, was the highlight of CES. It didn't get the press it probably deserved just because it doesn't yet run Windows, and I underline yet. I'm convinced it will run Windows shortly. I don't know when, but why would you go to that expense if you're not going to tap into the larger market? And that larger market is anxious to have something like Digits. It's got like 100 times the performance of any other AI PC out there, just in terms of AI performance. And you say $3,000, it's like less expensive for a PC. And I said, not for a PC that thinks it's a supercomputer. It's not too expensive at all. So I think it's a game changer. I think it's NVIDIA's way of entering the x86 dominated market for PCs and eventually even laptops, I suspect.
And it was so small. I mean, the
It
placard
looks just like a DGX too. The face of it looks like a DGX.
the placard to describe it
That's
and actually have the name on it was 4 times larger than the device.
Yeah, I would imagine we'll hear more about it at GTC in another month, over a month.
Yes,
I believe. But yeah, I think it will seal the show, especially if they can announce Windows.
Yeah, I thought it was kind of funny that some folks thought that the shield that Jensen brought out, was a new chip.
That was funny.
They said, wow, they have a wafer scale accelerator now. I was like, no. That's not what he was trying to say.
No, that was a joke.
Yeah. No, they don't make wafers that big. It was definitely interesting to see them bring that whole supercomputing story to the edge. I think that's really what it was all about. Physical AI, a lot of attention to that. But then, Jim, both of you guys are making a great point about NVIDIA bringing their AI PC story. And we've heard this in the past. Jensen saying, hey, look, we already have like 2 million AI PCs out there already. And this was even before AMD even introduced the first quote unquote PC processor that had the what you might deem an NPU. They didn't call that at the time, but that was like almost 3 years ago now, going on through 2 years, right? Is it 2 or 3?
And we've had 3 generations, at least 3 generations of NPUs running AI on them and capable of 100 to 1,000 times the performance of the processor AI capabilities with the NPU.
Yeah. And so, it's interesting to see NVIDIA bring that angle to the AI PC story. It's not novel, but it's definitely getting more, obviously, denser and in a much smaller form factor that's represented by digits.
Unfortunately, it all boils down to Microsoft support. So when Microsoft starts supporting AI on the discrete graphics cards and on the digits platform and everything else, that really opens up everything. But it's not just that. Also, it's also support on those platforms themselves. I mean, like if you use ROCm today from AMD, it doesn't run on Windows yet. So you're having to use the Linux platform, which isn't a big deal for a PC, but still.
Well, it's a big deal for users. It's not a big deal for developers. Developers are fine with Linux.
Yeah,
users.
That's a great point, though, right? And then it also begs the question of, well, number one, what do we mean by AI? Is it really the serious stuff, or is it the stuff that's kind of bells and whistles, ancillary feature type stuff that we're seeing, quite frankly, in Copilot plus PC, right? There's nothing there that at the moment that's really compelling. I think what we're seeing in terms of serious quote unquote AI is still cloud bound for the most part, right? And then it's moving its way to higher power edge infrastructure. But then I think this is the first time we're seeing at least NVIDIA bring that supercomputing capability or infrastructure, architecture down to a smaller form factor. No,
I would have agreed with you going to 2025 that there aren't really that many compelling use cases for AI in the PC at this point in time because most of it's in the cloud. However, I now see that a little bit differently. And that is the compelling use case isn't necessarily these applications that are using AI. It's AI itself. It's the ability to download Llama, to download DeepSeek, to download all these different models and be able to do development and models and modification of models and integration of models on your PC. I mean, yeah, that's still a smaller community than the broader ecosystem, but still, I think that is the killer app today. I think the killer app is the developer.
The killer app is a developer? Okay.
The killer app is being able to do AI locally for a developer, and just the power and the capability that we have to do that with.
Sure. I mean, but, the developer is developing application and, there's that broader question of, monetization that's still lingering out there.
Oh, yeah.
It's only going to happen through these scaled out and valuable applications. And I think that's really what I'm more referring to. I don't argue with you regarding, and that's, in terms of the value for the developer, because that's where I think actually NVIDIA might be bringing some serious gain in the approach that they're taking, which is what I consider top down. But then, I think maybe we don't dwell so much on NVIDIA, although I think CES, they made the biggest impression. But there was a lot of other stuff that happened, right? I mean, obviously, we still have some sort of that bottoms up stuff that's happening with what Intel, AMD, and Qualcomm are doing, right? And I don't know, what are some of your thoughts there? I know.
I think the world's still looking for the killer app, and to say it's the developer's true, Jim. But what I think people are looking for is, yeah, but I'm not a developer, so what does this mean for me, right? Yeah. And so that can go one of two ways. Either you make that person a developer by giving them the tools they need to create real value-added applications for themselves, or you realize that the real killer app isn't an app at all. It's the data. It's the data that's on your PC. It does not exist in the cloud except for in a backup form. That's where the AI PC could find real traction in making everybody more productive by helping them find and use and summarize data that's on their PC today. That's not dependent on the cloud. Qualcomm and AMD and Intel, they all talk about, well, it's all about being able to access data, be able to, process data on a free processor because you already bought it. Yeah, but the AI is becoming commoditized so quickly that cloud AI is becoming practically free. So I don't know if that's enough of an incentive to developers to create real value add apps on the PC itself.
Well, you're making some. I mean, these are obviously. We'll talk about DeepSeek later. Okay.
Actually, I think gaming is going to drive that, because I think gaming is going to drive it to a hybrid model like what we've seen in the past, where some of it's done in the cloud and some of it's on device. So I think gaming is one of those applications that's going to drive more and more of that AI processing on device.
You mean casual gaming or serious gaming?
Well, there's a fine line there. Depending on who you talk to, but yeah. I would definitely say serious gaming. I mean, we're not talking Android games. We're talking anything that is at least a AA or AAA game.
Well, and that's where I think NVIDIA's got a lot to contribute, right? I mean, Qualcomm's been very careful when they talk about gaming to talk about it as casual gaming, because they know you need an add-on, PC card, GPU card to handle serious gaming. But with digits, you don't. You don't need a PC. No. You don't need a GPU card. You've already got a Blackwell on your desktop. And that's where I think it could. Now, in terms of market size, it's a relatively small market when you look at the market for data center GPUs. But it is another differentiator, I think, for NVIDIA.
Yep.
Yeah, I mean, I'll be honest with you. I struggle a little bit trying to figure out where else other than, let's say, augmentation of non-player characters, generative AI in particular, that form, is really going to make a huge impact. Because, I mean, if you think about AI and how it's actually impacted game development, a lot of it has to do with, DLSS and the rendering engines and, improvements there that tend to be step changes. But in terms of, the grand scheme of things, these tend to be incremental improvements, right? I think it's the dynamism. How do you leverage these large language models or generative AI to introduce dynamism into the experience, right? Especially in the form of these non-player characters, is where I think there's differentiated utility, right? And that's always been like sort of the weak point of a lot of various, like gaming formats, whether it's first person shooters or open world type, fantasy adventure games. So I think we'll probably need to do a lot more tactical thinking to figure out where generative AI really fits and where it's going to express this like sort of exponential or logarithmic value everyone is talking about. I just don't see it, even though there's a lot of great visual representations or presentations of the impact. It's at a tactical level. I don't see it as being that that broad. It tends to be a little bit more narrow than what I think a lot of folks assume. But anyway, that's just my take. Now, what? Did I stun you guys?
No.
No.
And we need to have that, what do you call it? BS card, right? Like the little sound. We need that little soundboard.
No, we need the slap sound. But we don't have that yet.
No, we don't. We really, I can add it later. Maybe we do use sound gestures, like hand gestures for that. And then as cues, right? But I love you guys. Let's so yeah, the other announcements, obviously one of the things on the AMD front was the announcement of AI, the Ryzen AI 300 Pro. Was it Pro? Yeah, Pro, and then Dell coming on board with going enterprise or commercial with these guys. I think that was like a headline that really drew a lot of attention and excitement. Obviously, you guys are TIRIAS Research. You guys are at the Intel thing, right?
Oh
yeah. So, what's your take there? We have like Arrow Lake coming to market.
Actually, the big takeaway there, obviously Arrow Lake's coming to market, but the big takeaway there was Panther Lake. They were showing off Panther Lake, which is the next generation, and it's on 18A, which says 18A is on track and everything else. And I've actually seen, over the past month, I've seen some of the yield numbers on 18A. It is definitely on track. So when we start thinking about Generation Xeon, we start thinking of Panther Lake. All those products, in terms of manufacturability, are on track for later this year. So that was the biggest takeaway from me, for us at Intel's event.
Yeah. Okay. Yeah. I thought they were pretty stealth. They didn't get a lot of attention, but they were everywhere. I was at a bunch of OEM, like Samsung, Lenovo events, and you saw Intel folks everywhere. And so I think their go-to-market motion is a little bit stealth. In previous years, they were pretty boisterous, right? But it's interesting that I heard quite often, I was like, hey, where's Intel? They're so quiet. It's like, no, they're there. Well,
and their Meteor Lake Core Ultra is doing exceptionally well in the market. You have to remember that when they introduce products, every time they introduce a new product, they have more than 100 OEM design wins out of the gate.
Yeah.
So they are just there, and they're cranking, and they're ready to go. And Arrow Lake, obviously, the big thing there, which Meteor Lake lacked, is the fact that you can have a discrete GPU with it. So we're going to see those higher performance mobile workstations. We're going to see, higher, all those real STEM type PCs and everything else are going to be coming out using Arrow Lake as kind of the base CPU and using an AMD or an Nvidia GPU.
Yeah, and Qualcomm went the opposite direction with what you just mentioned here with the introduction of I think it's Snapdragon X, right?
Mm-hmm.
$600 and below.
The lower tier one, yes.
Yeah, lower.
They're building out their product family.
Yeah. I think they're going off of the smartphone playbook and trying to expand the footprint and support of Copilot plus PC because to the lower tiers because and actually one of the things that I noted in one of the reports that I am putting together is that they're diffusing Copilot plus PC with Hexagon, which has the 40 TOPS NPU compute much faster than what we've seen them do on the smartphone side of things, right? Historically. So that's an interesting dynamic and strategy that Qualcomm is executing on, I think, largely on behalf of Microsoft. So it's interesting.
Yeah, they're keeping that TOPS number up there, that NPU performance up there, and scaling the rest of the chip around it. So that seems to be the core.
Yeah. Anyways, I think that's CES. What else? What else was happening? We had a lot of stuff.
Unfortunately, I didn't get the chance to actually even walk the trade show floor because some of the vendors took up entire days at CES with events, Nvidia. But still, there was a lot of really, really good information there. I did get to see some of the other stuff, especially some of the IoT stuff. Synaptics had their Astra platform where they're being able to put AI in just the smallest devices. It's impressive. Some of the things that we're going to see coming out that are going to be leveraging companies like Synaptics, NXP. Even talking to the MIPS guys, which are now based on RISC-V architecture, and where they're going. They didn't announce anything at CES, but they are at Embedded World coming up, and the fact that they're pretty much supercharged around where they think RISC-V is going to go and how it's going to compete. Especially in this new dynamic where people are viewing ARM in a little bit different light after the lawsuit with Qualcomm in December. So. It's going to be interesting, and true to and good for them. The one thing that I'll note for them is the fact that they're not trying to be a pure IP company, because I don't think you can survive as a pure IP company in our industry anymore. You have to provide complete systems. You have to provide the software, the platforms, and even ARM's going that direction with trying to provide complete chips for some of their key customers. So,
but I think. That's where I think a lot of these companies run into an identity crisis and the challenges associated with it, right? Because they're positioned in a certain way in the ecosystem. So how do you reinvent yourself? And you've mentioned the challenges of doing that, and especially the impacts on customers or licensees. But speaking of the lawsuit, I know that you were there, right?
I was at the trial, yes.
Right, but it's interesting. Qualcomm filed what they call a post trial brief that was on like the 29th.
Yes,
a lot of people knew about it, but that's an interesting development or follow on to the trial, and I'm really interested to see how this particular motion plays out, but. Anyway, a lot of stuff going on in January. Let's talk about
one of the things that I'm interested in, and this is, how companies are using wireless and stuff. And there's one company, and this was their second time at CES. It's called Morse Micro. They're out of Australia. And it's interesting because they're using kind of older Wi-Fi technology or lower band Wi-Fi technology to get longer range. We're talking like a mile range, several thousand kilometers. I have one of their systems. I'm hoping to test it this week, but that might be a game changer in terms of wireless, because right now if you're using Wi-Fi, you're limited to, especially either, you're either using proprietary RF technology where you have to have line of sight, or you're using Wi-Fi where you're limited to a couple hundred meters at best.
Yeah.
And, having a long range Wi-Fi instead of having to do cellular and everything else, that could change the dynamics of the market. So I'm kind of interested in testing this system out. It's kind of interesting to me to see what people are doing. And obviously on the other end of the spectrum, there's other companies that are pushing Bluetooth and Wi-Fi to the lower power levels. So we're seeing a lot of innovation around wireless technology even outside of the cellular spectrum.
So are they using like beamforming or something like that to be able to
pretty much everyone uses beamforming, but they're also using lower frequencies. They're using, I think, 900 megahertz to I'm not sure how high they go, but you're limited to about, I think it's like 42 or 43 megabits per second rather than broadband speeds. But you start thinking about security applications, you start thinking about coverage of events and stuff like that. There's significance there, so it'll be interesting. I'm just seeing that, and we're starting to see NTNs. We're going to see more NTN this year, especially as we get into Mobile World Congress, the non-terrestrial networks, especially as companies start launching new satellites and new satellite networks. So there's going to be a lot of innovation, I think, in 2025 around wireless technology.
Okay, and this is coming out of CES, right?
This is coming out of CES, and I think we're going to see even more going into Mobile World Congress.
Okay. Well, let's then now dive into the topic that I know Karl really wants to jump into, which is this DeepSeek stuff. That was probably, arguably, the black swan moment.
Okay, the one thing I have to ask is, does anybody here believe that they trained those models for $6 million?
No, absolutely not. But that being said, it does show that, I don't want to be too accusatory here, but the U.S. engineering community has been so focused on just getting stuff out the door. And so they kind of keep all their programming at this level. The Chinese engineers didn't have the chip that would allow them to stay at this level and get the performance they need, so they came down a level. So it's a lot of hard work of optimization at the machine code level that they did, and a lot of innovation at the model level that they did to be able to get those costs down. Now, I don't think they did it for $6 million, but they definitely got a lot of attention. I mean, all of a sudden, everybody, including Nvidia, now supports it, and people are playing with it, and enterprises are trying to figure out whether they can use it or not. And if they do use it, is there any security concerns that they should be aware of and try to mitigate? So we haven't seen the end of this play out yet.
Yeah.
But obviously, it's a dual-edged sword. You bring the costs down, I need less chips. But the Devlin's paradox says, well, if you bring the cost down, then more people will use it. So you need more chips. And we don't know where that dividing line is going to fall. Yeah. We don't know whether it's net positive or net negative to the overall market. And from a volume standpoint, from a use standpoint, I think it's a huge step forward to making AI more pervasive and helping lower the costs, so you will drive more use cases. But again, we just don't know yet. We'll have to see what happens.
And that cost is the big thing. I mean, at their introductory price, they were lowering the cost over using OpenAI by 97%. 97% to do an inference processing workload. Now, that's just an introductory price. They're raising that up. But still, if you reduce that price by, 40, I think it's going to be 80% or somewhere around there, but even 40%, or 50%, you cut the cost in half. That really cuts the legs out of the current business model that's been developing around AI so far. And that gets to a very important point, the fact that we have to make it more cost effective. And I agree with you, Karl. I think I don't see a change in demand. I don't see people stop ordering GPUs because they still think they're going to need them. And hopefully this is going to spur more demand more than anything else. But it puts a lot of pressure. Even if they did use, illegally other people's models. And, that's still being decided. But it still puts a lot of pressure on everyone else out there in the AI community, not just to get stuff out there, but they have to be able to offer that inference processing of workloads on these models at a much more efficient price.
Yeah.
And it's interesting, it may actually drive increased demand for older GPUs. I've read recently that there's a lot of demand they can't meet for even A100s because they're cheap. And if you can get the job done using DeepSeek's model or derivative of that, then you're going to save a lot of money, but that will increase demand for older GPUs. I don't know that NVIDIA planned for enough wafer capacity to continue those product lines beyond what they would normally last, given the normal evolution of going from an H100 to a B100 on to the next generation beyond that. So it'll be interesting to see how it shakes out. We'll know a lot more in probably 6 months, maybe.
Yeah, and but here's the thing that everyone needs to reckon with is the economic impact. I hear this whole Jevons paradox thing. I don't quite buy it. I don't think there's way too much association of empirical laws, scaling laws, all kinds of weird theories about what's going on and what will happen. I think what we have to do is really look at the reality of what's in front of us. And to both of your points, they brought the cost of inference down ridiculously to a level that I think the current ecosystem, global ecosystem, primarily dominated by U.S. AI firms, it is disruptive. It changes the economics, and I think that's what the industry is going to be grappling with probably for the next 3 months. And in terms of the game theory here, whether or not they took the data or whatever these accusations, they need to be proven out. The fact of the matter is, the game theory is, if they in fact trained a certain aspect, of the model or a phase in its training, whether it's pre or post, at that cost, and comparatively, it is orders of magnitude more efficient and cost efficient, right? And with quality parity, which apparently they've achieved. That is the biggest risk to the U.S. led ecosystem, and I think that's the thing that everyone should be really concerned about. And I think there's a lot of deflection and denial going on around that, and I think that, frankly, is dangerous. I think if the Chinese, this company DeepSeek, actually prove that you can do all the stuff that we assume has to be done with these super massive data centers, right, that are going to create an energy crisis in a fraction of that footprint, a fraction of the resources required. That's game changing.
There's been two developments in AI in the last 6 months that I think change the slope. One is agentic AI, and the other is reasoning. Both of which are you read and watch demos of what this stuff can do. It's just mind blowing. But what they don't tell you is, but you can't afford it. Right? You can't afford the power, and you can't afford the cost of doing agentic AI. You can't afford it. I read an article today about OpenAI's new reasoning platform called Research, which is kind of a web search capability. But it would make Jim and I we do out of business just because it can do what we do and probably do it better. The problem is it's so expensive. It's only available to the $200 a month OpenAI users, and at that, I don't know that OpenAI is even making any money at it. If you apply the techniques that DeepSeek has applied, all of a sudden those kind of earth-shattering applications become much more readily available.
Yeah.
And that to me is kind of the next phase of AI where it's going to go, and it'll go this year.
Yeah. There's no doubt. Yeah.
There's two key points here. One is the fact that we always knew that using recursive training and knowledge distillation and these other techniques was going to bring down AI, the cost of AI, and make it easier to make more focused models, more efficient models, and everything else. And obviously, DeepSeek used some of these techniques. There's no doubt there. They had to. But also the fact that after they did that, they made it open source.
Yeah.
And that changes everything when all of a sudden they're willing to give it away to where you can download it, you can play with it, you can do your own research on it, you can do your own training or retraining and optimizations on it. That really changes the game. I mean, we've had a rush just to get stuff out there, but not a rush to really enable it. And that's really what DeepSeek has done, is enable it.
Yeah. But I want to get your impressions on this observation. Is that they didn't open the kimono entirely. What they open source was a fraction of what I think folks would have liked to have seen and wanted. They open sourced the weights. They didn't open source the data set, or even let people know what was actually used, even though there are references in their papers. And one thing that we do know is it was trained on data sets that were largely, off of Chinese content or data.
Yes, don't ask about Tiananmen Square.
Yeah. No, none of it had anything about it's obviously biased. If it was entirely done on let's say English Western, maybe there would have been some injection of some undesired hallucinations, but or at least on the part of the CCP. But the other thing is that they didn't entirely describe what the entire system looks like and how it comes together, right? What I noticed is a lot of people are taking the model and just running on standard, H100 instances, and they think that that's replicating everything. My impression, just reading and, reading a lot of stuff about, reading the reports actually, and doing a little bit of deeper diving, that those are things that haven't been replicated yet. Mm-hmm. And so I don't think the full picture of what the optimization actually is visible or even replicable. I think they've kept that close to the vest.
You're right. They have, and obviously there could be legal issues there if they are using somebody else's data set and or models. So you gotta kind of expect that. And once again, believing that they did this for $6 million, nobody really believes that. At least nobody that has ever worked on these systems believes that. So obviously there's information we don't have about it, but I think we're going to see. I think, and it's funny because it seemed like everyone thought that, this is going to crash the demand for chips, but this is going to raise up all these AI companies. I think it's just the opposite. It drives the demand for chips, and it opens the door to hundreds or thousands of AI companies that are going to look at what DeepSeek and theorize about what DeepSeek did and try to replicate it.
Yeah, but you know what? I think we're in an information digestion period. I mean, all the indications that hyperscalers are continuing to invest is that's a lagging indicator of the event, right? The DeepSeek event. What we need to see is what happens in the next 3 to 6 months as we start to learn more about what actually happened here and what what DeepSeek is actually trying to do. I think you're pointing out something really important. The fact that they open source this is just really curious. especially in light of what the Biden administration issued before they left office, which was that what do they call it? It is a goofy name, interim thing of AI diffusion.
AI diffusion, the terminology they used.
Yeah, I mean, it was almost like open sourcing. It was like thumbing their nose at that whole construct. You know,
absolutely. Well, open sourcing was really designed to really impact U.S. competitiveness in the marketplace, and really hurt the companies that are leading the research in AI, whether it's Google or OpenAI or what have you. So I think there were politics at play in that call more than some people believe.
Jim, your thoughts? You can't be quiet.
No, I completely agree. I think that well, you know, we've had AI diffusion. We've had the Stargate announcement about the U.S. government investing in this. Yes. And then we had the announcement of DeepSeek. The first thing I'll say is that thinking that any government, especially the U.S. government or Western governments, are actually going to regulate, impact, or do anything otherwise in this segment is kind of foolish when they can't even spell AI. And yes, it's only 2 letters. I don't believe that they are.
It means Apple Intelligence, doesn't it?
Token. That's one token, by the way.
The market, the industry, the technology is moving just so rapidly. And it also kind of points to the fact that this is a global ecosystem. And especially, you know, we've spent the past 40 years making it a global technology ecosystem and thinking that we can segment this and build barriers between countries and everything else to stop this. We can't. Matter of fact, if China locked down rare earth materials, our whole electronics industry would tank overnight. If we didn't have assembly in China, our industry would tank overnight. We are a global industry, and you know how many U.S. companies have developer resources all over the world, in China, in India, and you know every part of the globe. You know, you go where the talent is. So to think that that these tariffs, these regulations, or anything else, or even, you know, investment is going to have a huge impact on the direction of the market, the industry, the technology is absolutely foolish.
I agree. You can't contain this innovation, and by the regulations the U.S. government has tried to implement, this just shows that it didn't work. Right? It shows that that strategy is not working. So let's not double down on it. Okay, let's figure out how we can, first of all, get more talent in the U.S., not just through H-1B visas, but by investing in our education systems and getting more students trained. I mean, China's they're blowing past it just in terms of the raw wetware that's being applied to AI, and that's a long-term threat to U.S. competitiveness. You're not going to stop that by passing regulations preventing people from getting access to our technology. That's not going to work. We have to invest in the intelligence ecosystem, which starts with people.
I completely agree. Matter of fact, we should be investing in education. We should be investing strongly in the next generation. Now, I have 2 boys right now that are getting their masters in AI and robotics. So I'm doing my job. What are you 2 doing?
You know, I have
my daughter's a veterinarian, so that's not going to help.
I have a 5-year-old who I know is going to be designing the 8th generation of fighters of the future. So, you know, it can be an agentic platform. Come on. Yeah, I mean, he's already prototyping it right now. It's like ridiculous. I'm doing my job, Jim.
There's one area we should touch with. We're going to run out of time, but one area we should touch on briefly, and that's quantum. We saw a tremendous explosion in interest and investment dollars being poured into quantum in November, December, and then, you know, Jensen and Zuck both said, "Nah, this stuff is not real."
Yeah.
And just yesterday, Bill Gates came out and said, "No, actually, this is really going to happen. It's going to happen in the next 3 to 5 years." Meanwhile, IBM is quietly digging the trenches to fight that quantum battle, which is the next big battle that will come about. So if you take a look at what Google did with Willow, you combine that with Trillium, which is really an impressive chip. You start to get a feel that we are approaching an inflection point where everything's going to change. And both in terms, you combine that with the affordability that DeepSeek brings in, and you end up with a very different world than we've enjoyed for the last 2 years.
Well, don't you think quantum would just completely change everything anyways, especially as you're looking at neuromorphic computing and then maybe even having to go to a different architecture for quote unquote AGI, if that's what you're trying to pursue? I mean, I can't imagine that everything is just portable the way it is. You know, I mean,
quantum will coexist with traditional computers.
Yes.
You need to have traditional computers do pre-processing and post-processing and normal scalar operations. But you combine the concepts of AGI and quantum, and that's where the magic could occur.
Just the amount of processing you can do and the data you can process in quantum. And everyone right now is talking about how AI will benefit quantum, especially in terms of developing circuits and doing error mitigation and correction and everything else. But no doubt, eventually, quantum's going to benefit AI as well.
Exactly.
Yeah. It's just that, I mean, you mentioned IBM. I know that they've always been kind of conservative about expectations around quantum. You know, my concern is that there is this pivot, you know, to continue this AGI narrative, and it's just another hype cycle. I think that's the danger here, is that you start to place expectations on this as you start to see the economics of scaling, the current approach to quote unquote AGI kind of run its course and wear itself out. I think IBM, to their credit, at least 7 years ago, was the right one, where this is experimental. AWS, their head of quantum, said the same thing. This is like research stuff, guys. We're not ready to go commercial with this stuff, even though there may be some, like, you know, applications like in the early days of supercomputing where you might be doing weather models with this stuff, or molecular biology research and things like that, or maybe even drug discovery. I mean, that one always comes. But these are like supercomputing themes that will continue to find a new home in the next generation of computing. But in terms of like revolutionizing things on your smartphone, let's not get our hopes up too high. You know,
no, it's a data center play, but I think that it advances the data center significantly, and even Nvidia would agree with that. I think by 2030, with the advancements we're seeing especially with error correction and with bit development, talking to Alice and Bob about their cat bits this morning, and how they're using a feedback loop to, reduce the bit flipping. I mean, this is a physicist level challenge, and there's so many different qubit technologies under development and under consideration at this point in time. But I agree with Karl. I think by 2030, we're at a point where you have to be invested in taking quantum seriously, because it raises the bar again.
Yeah. I mean, no doubt when it happens. I think it's always a matter of timing, right?
Okay, are we ready for the...
Okay, so here, let's do this. Since this is the first episode of 2025, and we're all just completely baffled with
and brain fried.
Totally brain fried. And, yeah, unfortunately, we're not going to do this 5-hour thing that, Lex Freeman does, even though, we're trying to do something much denser, But I'd like to get both of your impressions of what we can expect in 2025. I know it's so cliche, but let's just do it. I know that you guys have.
Jim and I were talking earlier. We were both working on our annual "Here's what to expect in the coming year" vlogs, and I stopped writing it because I have no idea. I really don't know what's going to happen this year. I do think that we're going to see a shift where the return on investment of cloud computing companies and other challengers to Nvidia, including Intel, which has just canceled, their next big AI chip. They canceled it. AMD's, we'll see. Lisa's got a call tomorrow. We're going to find out more tomorrow, I guess, but it's not clear what market they're pursuing. You've got NVIDIA and you've got all the cloud providers. Where's room for another, a commercial semiconductor vendor to come in and say, yeah, well, I've got a better solution here. And that'll apply to Intel, apply to AMD and all the other startups out there. And so they're all going to be scrambling to find a niche they can fill and own. I'm not sure where that's going to land. I think at the end of the year, NVIDIA is even stronger as probably the only viable commercial semiconductor provider of AI accelerators. What do you think, Jim?
Well, I would agree with you in the fact that they have the complete stack from the Jetson platform all the way up to Blackwell. And they're looking at the whole solution. They're looking at the complete software stack as well. So I don't think anybody has the vision that they have. And the fact that the entire industry right now is focused on going towards agentic AI, and they're already looking at physical AI. Right. And I think they're doing it right because they're the only player in there. There's no one else there. And if you saw some of these humanoid robots at CES, they were impressive. So, I think that we're getting to, I think 2025 is a year of practical AI. I think we see a lot of AI start moving into practical applications, whether that's for the chatbots or the productivity tools for the enterprise, or whether that's actually for embedded systems that add more intelligence. Now, not necessarily generative AI, but even just traditional AI.
Yeah.
We're seeing practical uses of it throughout 2025. Once again, I think we're going to see more innovation around wireless technology that kind of build up to the next wave, which is going to be 6G, it's going to be Wi-Fi, it's going to be Bluetooth, it's going to be all these, but they're expanding as they go. So I think I am excited about some of that stuff. Definitely, I think that quantum is. Let's put it this way. I don't know where the huge innovation things are going to happen because there's so many things going on, from silicon technology to software technology to physics technology. I would say that is probably the theme that we're going towards 2025 and beyond, is that we're now not just looking at, battling Moore's law. We're not looking at scaling, Dennard scaling and stuff like that. We're battling the laws of physics, and we're trying to address the limitations that we have with physics. And that's going to lead to a whole new wave of innovation, whether that's this year or beyond.
Yeah. But hasn't that always been the case, though? That's the thing, right?
In some ways, but I think you're going to a whole new level. Whole new level.
Yeah. Well, it's an entirely different technology, in a way, right? So, yeah.
But I think that 2025 is also going to be filled with a lot of despair. We don't know what's going to happen with the socio-political situation that we have between countries and governments at this point in time. And quite honestly, they could tank everything very quickly. So I'm very concerned about that. Very concerned about building up barriers between countries, especially when we have a global industry. I'm worried about the distribution of talent, which Karl brought up. Definitely worried about, trade wars and tariffs.
Yeah, definitely.
I think people make the name of my company is Cambrian-AI, but what happened after Cambrian-AI? A mass extinction event. Six of them, five, depending on whether you believe we're currently in one or not. So I don't know if there's going to be a mass extinction event of companies developing AI, especially companies developing AI chips or not. And I think Jim's point about the current socio-political environment probably will have more impact on whether this is a mass extinction event or a continuation of the Cambrian explosion of AI.
Yeah. So that doesn't mean
there's your headline. Karl Freund predicts mass extinction.
Well, no, actually, what I'm really curious about is, are you going to be rebranding to a Cretaceous hyphen?
Probably Devonian.
That's what I want to know.
Right? That's what followed Cambrian was Devonian, and the Cambrian-Devonian extinction event. Yeah. No doubt.
What about you, Leonard? Come on. What's your prediction for 2025?
My prediction. Well, I have thoughts. Number one, I think generative AI supercomputing, or this AGI supercomputing, is going to have to reconcile with new economics. And then these are realities. These are real economic shifts that are happening, and it's going to create opportunities, in certain parts of the quote unquote ecosystem, but then it's also going to maybe be that extinction event for others. The other thing, I think the AI PC hype is going to settle this year. I think we're going to find that the CPU and the principles of XP are probably going to dominate and be more relevant for AI in general or at large at the edge than what we're seeing in the, what the industry and the media and the broader public thinks of the GPU oriented world of AI computing. The other thing, maybe a move toward custom training systems and inference. So optimizing, because if there's credence in what the DeepSeek folks have done, and there's this order of magnitude improvement that you can get across the board, there's probably going to be focus on that, especially, like when you look at the hyperscalers looking to operationalize a lot of these models and incorporate it into their recommender systems and, agentic platforms. It has to be cost efficient, because a lot of this is going to be given either away for free, or it's going to be monetized through a freemium business model, like what Meta does, right? Mm-hmm. And then I think, I think there's just going to be, like on the enterprise side, just simply a digestion issue. The systems, you guys know. I mean, we're on this friggin', 1 year cadence at the supercomputing level. Think about what's happening across the edge environments, where systems are evolving probably way too fast for a lot of enterprises and consumers to really deal with. And so I think that's a dynamic that the end markets are going to have to grapple with, and obviously it's going to have impact up and down the ecosystem. Across the ecosystem and up and down the stack. So those are my thoughts.
A lot to think about. It's going to be a fun year, that's for sure.
Maybe we should be doing these every week. No, just kidding.
I know. I was thinking we should. Otherwise, we make this like a 5-hour thing. And then we'll have to use AI to edit the whole thing, and then maybe hallucinate in between. So anyway, but hey, it's great catching up with both of you. Hopefully we'll have a calmer February. I doubt it, but I'm almost dreading getting back on for next.
we have a lot coming up. I mean, Mobile World Congress is coming up, Embedded World, followed by GTC.
Yep.
There is just on and on and on. There is a March is ridiculous. I don't think I'm home more than 2 days.
Yeah. Yeah. All the more reason to watch our podcast here, the Silicon Futures podcast here. And gentlemen, thank you so much. Everyone,
Yeah, it's fun.
if you wanna get in contact with Karl, make sure to reach out to him at Cambrian-Research LLC, and I think it's a .com, right? But he's on LinkedIn. Reach out to him, and of course, there's Jim McGregor of TIRIAS Research. Just go to www.tiriasresearch.com.
Or Jim at TIRIAS Research.
Or Jim. Okay, there you go. And connect with both of these gentlemen. They are thought leaders in the field. And of course, reach out to NextCurve at www.next-curve.com. And remember to like, share, comment, share your reactions to this podcast episode, and subscribe to the NextCurve Rethink podcast on YouTube as well as Buzzsprout. And we will see you next week or next month, right?
Yep.
Back here to recap the month of February, which we hope is a little bit more mellow.
Never.
Okay.
All right. Thanks, Leonard.
Take
Good
care.
to see
Thank
you.
you. Cheers,
Take care, guys. Thanks for watching, everybody.